board when I say, like, here, there, this, that, because Audrey's going to have to, hey Audrey, she's going to have to watch this, and sometimes I forget to touch the board, so you can't see where the pointer is. Okay, 6-4. This is going to take us 4 days, because remember what I said, the reason we only cover 3 chapters is because they are dense. Okay, this is going to take 4 days. Today's probably the shortest of it, because one, I want to make sure to go over a couple of things that I saw commonly missed on the mid-exam, and then we'll dive into the new part. One of the things that I saw several people miss was if there was an angle, for instance, it was negative 540 was one of them. I don't have my calculator on me. But anyways, it was saying, like, tell me the tangent of negative 540. They don't want you to type it in the calculator because it's going to give you a decimal. They want you to calibrate it down to a reference angle. But in order to do that, we need to find the coterminal angle first. Then we find the reference angle. Those are totally different things. Coterminal angle means the exact same landing spot, but a difference of 360, right? There's a full rotation in between. So this is too small, so I would take negative 540, and I would add 360. Tell me what you get. Negative 180. Okay, that's still, I mean, I know where that is, but I really want it to be positive. Because another common mistake was several people forgot negative angles rotate in a different direction. So negative angles start on the positive x, but then they rotate clockwise, right? So I'm going to, even though that is 180, which means direction doesn't matter, I'm going to add another 360, and then you get 180. So the tangent of negative 540 is going to be the same as the tangent of 180. And then that is a quadrantal angle because it lands on one of the axes. Where does it land? It lands right here. And you had to think of the coordinates of that quadrantal angle. Those coordinate points are either 0, 1, 0, 0, 1, negative 1, 0, or 0, negative 1. This is the one that it lands on. Tangent means y over x, so it would be 0 over negative 1, which is 0. Now, could that have been reversed, it would be undefined. Okay, so that one didn't have a reference angle. That was a quadrantal. Let's say negative 570. This should, we'll just do negative 510. All right, negative 510. Negative 510 plus 360. What's that? Negative 150. All right, that's still out of my scope. I want to add another 360. 210. Okay, that's between 0 to 360. You got to imagine where that lands. Okay, so the tangent of negative 510 will be the tangent of 210. This is called a coterminal angle. Coterminal lands in the same spot. Now I want to find the reference angle. So where's 210? It starts here. This is 90, 180. If I go all the way to the next axis, that's 270, right? So I don't go all the way. I'm going to land about right there. So this is 210. The reference angle is always the gap from the landing angle to the x-axis, the nearest one. You have to think of what measure that x-axis represents in terms of how far you've rotated so far. So what's the gap from 210 collapsing back to 180? There's a gap of 30. So that means that when you find the tan of 210, you could just find the tan of 30 from your chart, but you need to remember you're in quadrant 3, which means tan is right. But you need to think of what's the sign of tan in quadrant 3. The reason it's positive is because tan is y over x, while in quadrant 3 both y and x are negative. Then you'd go to your chart and you would just read the chart. Several people got this wrong. We did practice this in the notes, and I remember saying to y'all that this was something that involves several steps, and it's so easy, like as far as looking at the chart, that you overcomplicate it, and that's what happened with a couple of people. But anyways, that is important to know because of where we're going, okay? We're getting into radians, which means we're no longer looking at degrees, we're now looking at radians. Radians are fractions, so you're going to have to embrace fractions, and I'm going to show you ways to hopefully get comfortable with them, because that's 6-4. That's the unit circle. Is hold on, it crashed. 6-4. The unit circle revolves around radians. Nope, because you crashed again. Okay, hopefully it was all safe. Alright, so now let's dive into 6-4. We only have a couple of slides to go here because you really, I think we only have 3 slides. We do. Maybe not 3. I have a stop sign for me to tell me when to stop. You really have to wrap your mind around what a radian is and understand it before we dive, we get even further into it. Okay, so turn to this right here. If you have a highlighter, because there is about to be a lot of information on these notes, I would get a highlighter. If you need one, I have some. If I need one. If you have your own highlighter, that's fine. If you need one, I have some. It is a scientific fact that highlighting your notes in a strategic way does help with comprehension and retention. I know you're catching up. Make sure you catch this too. Okay. The first thing you need to highlight is this vocab word right here, unit circle. You are going to hear this a lot. I hope that you're going to love the unit circle by the time we're done with it. The first time you see it, you're probably going to hate it. The second day, you're probably still going to hate it. And then I think by the third day is when people actually start to like it, because I show you the tricks on filling it in. What is the unit circle? It's exactly what it sounds like. It is a single unit of measurement that creates the circle all the way around. It has a radius of 1, and it is always centered right on the origin. So it's like perfect. It has a radius of 1, and it's always centered on the origin. So this particular point right here, x, y, if I was to draw the radius from the origin to that point, it's still length 1. And then if I was to draw the right triangle formed by it, this would be the x coordinate and this would be the y coordinate. We're going to look at the lengths of the triangles formed by any given point around the unit circle if you draw the right triangle. We're looking at the distances on the unit circle. Remember the word circumference in terms of a circle is a fancy circle word for, starts with a P, circumference means perimeter of a circle. I don't know why, but at some point in the creation of geometry, math, all that, whenever they dealt with a circle, they changed the word. Like a circular pyramid is actually a cone. A circular prism is actually a cylinder, right? So you see what I mean? And then so the perimeter of a circle, they're like, oh, that's too boring. Let's call it something different. They call it circumference. Do you remember the formula for the circumference of a circle by chance? Close. So it's C equals 2 pi r. C equals 2 pi r. R stands for radius. That's the good old-fashioned formula of circumference from, I don't know what point y'all first learned it, maybe middle school, maybe. You're stretching. Okay, what is the length of our radius in our unit circle, though? Our radius is 1. Remember the name unit is telling you 1 all the way around. So if we have r equals 1, then what is our modified circumference? I'm going to draw a big arrow to say, like, okay, that's the formula for circumference. If our radius is 1, then our circumference is actually just 2 pi, right? It'd be 2 pi times 1. Well, 2 pi times 1 is just 2 pi. If you need to understand where that came from, then put right here, 2 pi and then a 1. And what is 2 pi times 1? It's 2 pi. If you need to understand where that came from. This is the takeaway right here. What is the distance all the way around the unit circle? It's 2 pi. So I want you to make a note. Circumference of unit circle. And then draw an arrow. The circumference of the unit circle is 2 pi. That's really important. If I ever say, what's the length all the way around, you need to say 2 pi. Now we are getting into radians, and we're actually already dealing with radians right now. I just haven't actually told you the word radian. So now here are 4 examples to help you visualize the rotation. So look at the very first one. We have what starts right here, and then it traces all the way around. We're going around the unit circle. Oh, I knew that was going to happen. I'm trying to stay on there. All the way around. Bam. All right, so full rotation is what? 2 pi. Let's make a note. 1 rotation. 1 rotation is 360 degrees, which is 2 pi. Okay, now, don't look at the picture. Now, just in common sense. If a full rotation, let's see, I'm backwards from y'all. If a full rotation around is 2 pi, then what's half a rotation? Pi. Right? And how many degrees is that associated with? 180, because half a circle is 180. Okay, so right here, you can see, starting on the initial side, and if we only go halfway, which is 180 degrees, then we have covered pi distance. So I'm going to make a note. This is half a circle. to call these our anchor values. And I say that because they're kind of like calibration points. Like you always think back to yourself, what's full rotation? 2 pi. What's half? Pi. Because this is where you're going to start getting in how to label the unit circle from memory. Okay? Now look at the last 2 examples that are up here. If I take my entire circle, think of it as a pizza, and I cut it into 4 equal slices, and I'm only referring to, well, I'm sorry, not the whole circle. Look right here. From here to here says pi over 4. Here's why. I'm going to change colors so you can understand why. From here to here was 1 pi, correct? Okay, so if I cut that 1 pi into 4 equal parts, look, 1, 2, 3, 4. You see that? And then if I'm only talking about one of them in blue, it would be deemed as pi over 4. So another way to think of the pi over 4 is 1 pi over 4. 1 slice out of the 4 that I just showed you. You see that? I'll show it again just in case. So calibrate it back to 1 pi. 1 pi goes from the initial side to 180. Cut it into 4 equal parts. Well, right there cuts it into 2, and then cut those in half. So now you have 1, 2, 3, 4 equal parts. So if I was talking about pi over 4, then I'm saying go 1 of the 4 equal parts. You see that? Look at the next one, same concept, it's pi over 3. That means from the initial side to the 180, we've got, you have to be careful here, there's extra tick marks. This is 1/3, this is 2/3, this is 3/3, right? So pi over 3 refers to, bless you, taking up one of the 3 slices that are equally formed between 0 to 1 pi. Okay, that's a lot to take in. Let's practice working with that without pictures drawn. Go to the next slide. How far will a point travel if it goes blank of the way around the unit circle? Keywords here. Around the unit circle, you need to immediately think, what value is that? What's all the way around? 2 pi. It is 360. I need you, we're starting to now answer with pi. So this is 2 pi, okay? So we are just finding what fraction of 2 pi here, and we're just cleaning it up. So if I go 1/4 of the way, then I'm saying what's 1/4 of 2 pi. Keep it a fraction. If you need to, you can go to your calculator and do this using the fraction shortcut, or you could just visualize in your head. The 2 is understood to be over a 1, and you multiply straight across. So you end up with 2 over 4, and what does that reduce to? Half. So this would be 2 pi over 4, which is 1/2. Do not write the 1. Don't write the 1. Write pi over 2. This is the answer. Don't write the 1. That was another thing I saw with just a few people. They were typing a 1 in the exam where you weren't supposed to type it, and it marked it wrong, which I went in and gave you credit. All right, so now let's find what fraction of the entire unit circle would I get if I traveled 1/12 of the way around. So 1/12 of 2 pi, multiply straight across, you'd end up with 2 pi over 12, which reduces to pi over 6. All right, you do C and D. You are keeping it in a fraction. If you're not good with fractions or reducing, remember the fraction shortcut, alpha y equals on your calculator. There's nothing wrong with using that. Or you can do it in your head and then use that to check your work. Did you get 3 pi over 4 and 5 pi over 3? So what is 3/8 of 2 pi? You can go straight to your calculator and do it. So alpha y equals, don't enter the pi though. If you enter the pi, it's never going to give it back to you as a fraction because pi is irrational. So 3/8 times 2, and you get 3/4. You would have to remember to write the pi. If you're doing it in your head, multiply straight across, you got 6 pi over 8, and 6 over 8 reduces to 3/4. Okay, so what you've done when you answered this question, you have just found the radian measure of the rotation traveling around the unit circle at these specific fractions. And you do that by simply finding the fraction of the full rotation, which is always 2 pi. Okay, now let's look at this part. A point may travel completely around the unit circle and then continue, or it may travel in a negative direction, which remember means what? Clockwise, like we saw in 6-3. So we may have rotations that, y'all know, I've said it before, when I say calibrate, I mean between 0 to 360. So we may have rotations that go past 360, or they may, in the other direction, rotate in a negative direction, clockwise, past what, I guess, 0, because if it's negative, it's go like this one right here. This one's starting there and rotating negative. Okay, so let's take some notes. All right. So what you have to ask yourself is, what quadrant is it landing in? You have to visualize the rotation. Just remember that this over here is what's called the initial side, where you start. Remember that you're rotating counterclockwise for positive, and you're rotating clockwise for negative. If you forget that, remember how you label your quadrants with positive numbers. is in the counterclockwise direction. Okay, so look at this rotation. I'm not going to trace it because it's ridiculous. But it's starting on the initial side. It's rotating a full, we don't want to say 360 anymore. We want to say, I'm going to mark that right there. We're going to say 2 pi. It's rotating a full 2 pi, and then it's continuing on with an additional 90 degrees, which lands at what's called 5 pi over 2. So 5 pi over 2 is the actual radian measure for this complete rotation plus some. Okay, and it lands on a quadrantal angle. Start embracing fractions and thinking to yourself, the full rotation was 2 pi, right? The full rotation was 2 pi. Okay, now what's the extra? It'd be a half pi or pi over 2. And the way to remember that is go back to our anchor examples. We've already got the full rotation. Think to yourself, a half a rotation is considered 1 pi. So if I only went half of the half, right here, I would end up with pi over 2. Does that make sense? Because this is a full, so this is halfway. Okay, so back over here, from here to here is a pi over 2 rotation. Now you might be wondering, how is 2 pi plus pi over 2 going to give me 5 pi over 2? Because of the good old adage, you have to have a common denominator and you add them up. So, and we're not doing that right now. There's no reason for you to sit here and try and do that in your head. 2 plus, what's this fraction? It's 1/2. If you want to type that as a decimal, you can. And then you can hit math, frac, 5 pi over 2. Remember, don't enter the pi because it won't give you a fraction. So, right here, we're going to say that this was 5 pi over 2. And that was a full rotation plus a pi over 2 rotation. Look at this next one. Notice this is starting on the initial side, but then it's rotating in the clockwise direction, which means it's negative. And it's negative pi over 4. It is the exact same concept as going back to the last slide, this one right here. It's just in the negative direction, okay? So, let me take that mark off. So if you think about it, from here to here is 1 pi, right? Negative pi. Cut it in half, then cut those in half. So you've got 1, 2, 3, 4 nice little sections, and this is traveling one of them. I'm really trying to drive home the visual, like with a pizza, I guess you could say, in fractions. Or with a pie. I'll leave that there in case you need it. Look at the next one. So this is a negative rotation starting here. It's going one quadrant, another quadrant, and this quadrant landing there. It is negative 3 pi over 2. Here's how they got that. From here to here is negative 1 pi over 2. You can say the 1, don't write it. This is negative 1 pi over 2. Keep counting. Count your fractions. To here would be negative 2 pi over 2. What is 2 over 2, y'all? 1. So do you see why that's the pi again? I'm counting with my fractions though. This is negative 1 pi over 2. This is negative 2 pi over 2. So, and I actually don't like that being right there. When it lands right here, it would be negative 3 pi over 2. It's just counting, okay? So here's a question. What quadrant is dot, dot, dot. Let's do 2 examples. 9 pi over 4. So you got to think about what quadrant does that land in. When it's a fraction that you may not be comfortable with, of course it's over 4. I'll show you one way to count it. You could go to your calculator and you could get the decimal of it and then translate the decimal to a mixed fraction. Okay, so 9 divided by 4 is 2.25, right? So I'm going to make a note here that 9 over 4 is 2.25. So in terms of a mixed fraction, we have 2 pi plus, what's 0.25 as a fraction? That's a quarter. Think of money. That's a quarter. So that's pi over 4. So 2 pi means a what? A full rotation, which means you really, I mean, you can visualize it, but you're starting. You land right where you started. And then the pi over 4 would put you landing in what quadrant? The 1. So this is going to put me in quadrant 1. Let me show you another way to visualize it if you actually are good and comfortable with fractions and counting. Think of them as counting. I'm going to erase this so that you can see what I'm about to say. Ignore the red there to show negative. All right, so in terms of counting, remember from here to here is 1 pi, correct? And we said if you cut it into fourths, so like that, right? This would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4. 4 pi over 4, it's a 1, see? 5 pi over 4, 6 pi over 4, 7 pi over 4, you see where this is going? 8 pi over 4, it's a 2, 9 pi over 4. So it's just counting, okay? So if you're good with fractions, you could also just count it. If you're not good with fractions, you can get it to a decimal and then translate that to a mixed fraction, meaning there's a whole part and then there's a fractional part. But I am going to try to get you comfortable with the counting like this, because when we label the unit circle from memory, it is just counting. You're not actually memorizing anything. You're counting. Well, there's one small spot, but the rest of it you're counting. Okay, let's try another one. Let's mix it up and go in a different direction. Try negative 7 pi over 6. The question is, what quadrant does that land in? Negative 7 pi over 6. So the negative is just telling you to rotate in a different direction, right? Than what you're used to. This is only the second example, so if you're stuck, makes sense. It's okay. It's just the second example. One method, go to your calculator. -7/6 in your calculator ends up being what ugly decimal? -1.116 repeated?
166.
Oh, with the 6. Okay. So in the calculator, -7/6 ends up being -1.6 repeating. Oh, 1/6. Like that. Okay. So I don't know off the top of my head what 1/6 repeating is as a fraction, and that's where the counting would be really helpful here. But you can see that there is the whole part right here of -pi, right? That first whole number lets you know there's a -pi. Now, since it's an ugly decimal that's repeating, go to your picture and then count the fraction out. All right, so we're doing -7pi/6. The negative tells me on my initial side, I'm just going to use this again. The negative part tells me on my initial side, I'm going to rotate in this direction, right? Okay, so the whole part is -pi. You need to equate that to half a rotation, or 180. So from here to here is -pi, right? Because all the way around would be -2pi. Y'all with me? So only halfway would be -pi. Now count your fraction. This is 7/6. Don't worry about the negative. That's just the direction. This is 7/6. The whole part would be 6/6. Right? What equates to 1 with the 6 in the denominator? 6/6. Y'all with me? So it's going past that by 1 additional 6. So this would be plus a -pi/6. Go back to middle school and think of mixed fractions. 1 plus 1/6. Go to your calculator and test it. 1 plus alpha y equals 1/6. Oops. 7/6. So you can check yourself. Okay? I actually think there might be. Is that? Can I think I can. Look, let's see. 7/6. Get the math. No, not the math. Alpha. Alpha y equals number 2. No. It's got to work.
Are you trying to put it into?
Will it convert? Will the calculator convert from an improper fraction to a mixed fraction for you? I thought it would.
I think you were right on the math part. I forgot how to.
Throw up. I'm trying to see if there's a shortcut in the calculator. There's got to be math. Okay, let's get what's already in fraction form.
If you go to math and then go all the way over to frac, I think, and then hit number 2, maybe. Oh, no, I just did that.
It doesn't pull up that arrow like it's like it's a function.
Like it's an equal.
What if I type what I suspect? 1/6, and then type math frac. Okay. So you could check yourself. You have to come up with an answer first, because clearly you just saw that it makes you put an answer in. Did you find it?
Yes, number 3 on alpha y equals.
3?
Yeah.
Convert. There it is. Okay. All right. Look at that. Teamwork. All right. So you have to enter the given fraction that's, remember, called improper, because numerator's bigger. Then alpha y equals number 3 is the conversion of an improper to a mixed. Beautiful thing. There you go. So it would be, now you have to know how to read it. 1 1/6 means 1 pi, which is half, and then just 1/6 of the way, right? To the next half, to the next 6/6. Okay, so this would land in quadrant 2. Oh, I meant to take this off. This would land in quadrant 2. Is that there? Another way to do it is like what I was doing a second ago when I said that, this would be 6/6. That's a 1. Then I know it's 7/6. That means just go like 1/6 of the way. So that's another way. Go to the next slide. Radian measure. Okay. We're getting away from degrees and we're looking at what's called radians. They're the same thing. It'd be like 3 feet is the equivalent of 1 yard, right? Totally different numbers, totally different units of measurement, but in terms of the measurement that they actually, like if you were to lay tape down 3 feet long, then someone else laid tape down 1 yard long, they're the same, right? Okay, radian and degrees have the same relationship. Totally different words, totally different looks, but they measure the exact same, they're equivalent. Where did the word radian come from? This is so stupid, but it helps me visualize it. Okay, what is the length of the radius in the unit circle? 1. Okay. I want you to think of an uncooked spaghetti noodle, angel hair pasta, uncooked. Okay, that means I could hold it, right? I don't know about y'all, but I eat raw pasta. When I'm cooking spaghetti, I'll stand there and I eat it. But anyways, you have an uncooked angel hair pasta noodle. It measures 1. When I cook it and take it out of the pot and throw it against the oven to make sure it's done, you don't do that? Your mom do that? Dad? No. You throw pasta, you take a little bit out and you throw it against the stove or the oven, and if it sticks, it's done. If it falls off, it's not done. Yeah. Anyways, it's a good old, it's from the 80s and the 90s, baby. Take the noodle out, it's cooked. It still measures 1, right? It's just now I can't hold it. Now it's a noodle. It's a cooked noodle. Okay, take the cooked noodle, lay it starting right here, and lay it along the unit circle. Remember, it still measures 1, but now I can curve it, right? Enter radian. 1 radian came from taking the 1 radius, cooking it, and laying it along the unit circle, and that's a radian. The actual number behind it, it's over here somewhere. It's about 57.3, which is not that important. It's good to kind of keep it in the back of your mind so that if you ever say that the answer is 1 radian, and let's say we're in quadrant 4, that it was a positive rotation, you should know that it can't be 1 radian because, it's 1 radian would be 57. If we were rotating all the way around quadrant 4, we should be closer to 360, right? So it is good to kind of keep it in the back of your mind, but we will just refer to it as a radian. But that's where it comes from, okay? You think of a cooked spaghetti noodle laying along the unit circle, and that's what 1 radian came from. Right here, theta is 1 radian, which is the 57.3 degrees, approximately. You can see in this picture here they've given you a visual. If you take 2 radians, since that does end up being past 90, it would land you in quadrant 2. 3 radians would land you still in quadrant 2. If you had 6 radians, it would bring you all the way in quadrant 4. All right, go to the next slide, which is where we're looking at our quadrantal angles, but in terms of radians. We've got all 4 of them here, and these are 4 more anchor points, like to help you stay calibrated, okay? The first one, you're used to calling it 90 degrees. We are now going to call it pi over 2 radians. Oh, Lord. We are now going to call this pi over 2 radians. And that means from the initial side up to the positive y-axis. Let's make some marks on here. From the initial side, all the way around is what? 2 pi. So from what I'm doing right now, by the way, is what you'll start prompting yourself in your head as you're doing like the practice problems. From the initial side, all the way around is 2 pi. So from the initial side, only half of that would be 1 pi, or pi. So if I was going only halfway to pi, it's pi over 2, which is equivalent to 90 degrees. Okay, what if I was rotating for 2 quadrants? Well, the full rotation is 2 pi, so half of 2 pi is pi, which is equivalent to 180 degrees. We are now going to refer to this as pi radians. Now the next one is 3 pi over 2. Let me explain how they got it. You are rotating through 3 quadrants. Always count by the denominator. So the denominator is 2. You have to think of the very first unit. So where's 1 pi over 2? 1 pi over 2 is right here. Right? Then this is pi, but we're going to count by the denominator. So this is 2 pi over 2. So then what's this one? That's where the 3 pi over 2 comes from. You've counted 3 blocks of a pi over 2 rotation. You counted 3 of them. The equivalent in terms of degrees from here to here is 270 degrees. And then, of course, a full rotation is 2 pi or 360 degrees. This is laying the groundwork for filling in the unit circle from memory, is this right here, okay? I know today you're going to feel like this just got really challenging, but because this is what we were now going to be doing every single day, I promise it does get easier as long as you are practicing it. Math is just like a sport. If you don't go to practice, coach is not going to put you in and you're not going to be good, okay? Look at the next slide. what if I want to convert back and forth from degrees and radians, okay? So the relationship is 180 degrees was what in terms of the radians? Pi, right? So that's your calibration, like that's your unit of measurement that you use to convert. So make a note right here. Recall that 360 degrees around was 2 pi. Instead of writing the word radians, I'm now going to just write RAD. So if 360 was 2 pi, then half of that is just pi. When you are converting back and forth, you have one of two scenarios. It's either pi over 180 or 180 over pi. And the reason why is because those two are equivalent, right? If you're converting 2 radians, you're going to multiply by pi over 180. If you're converting 2 degree, you're going to switch it and multiply by 180 over pi. Make note right here, not on the formula sheet. You're going to have to memorize this. This is going to be something you memorize and write on your formula sheet as soon as we start. Let's tweak this. If we're going to radians, what appears in my measurement? A pi, right? Every time. If we're going to radians, we're going to end up in pi. If we're going to degrees, we're going to obviously end up using a degree symbol. Yes? Here's how you know which one to use. This is a stupid, corny way. Make a note. Draw an arrow. The top in big capital letters is the form you want. The top number or value is the form that you actually want it to be in. So, for example, right here, it is in degrees. I want it to be in radians, right? So I'm going to multiply 120 times pi over 180. And then you would go to your calculator and you would enter that like you did at the very beginning. Just don't type the pi in because then it won't give you a fraction. So you would say 120 divided by 180 to decimal, get math, frac, 2 over 3. So the answer would be 2 pi over 3. We'll pick up on this tomorrow.